doing transformations. Okay? What does it mean to transform?
Change.
It means to change. And so you're going to be doing transformations, and so you are all going to be transformers for this unit. You can go around saying you're a robot in disguise, and you won't be lying, because you are going to be doing transformations. Okay? Behold, a triangle being transformed. Okay? For math, a transformation is an operation, we call it mapping. Okay? Which just means to change it. Okay? And we're going to take the original figure, whatever it is, and map it onto a new figure. Okay? What should we call those? We need a fancy math word for those. Well, that's what we're calling the movement, but what do we call my original figure and my new figure? Because those need fancy names.
Pre-image and image.
Those are called the pre-image and the image. And what do you think about why they're called that? All of you people who use your phones to do social media, Snapchat pictures, all that crap, is the thing on your phone the original you?
Yeah.
No, it's an image of you. The new figure on your phone that didn't exist before you took the picture is your image. The thing that existed before the picture is the pre-image. So every one of you is a pre-image right now as you sit here. And then every picture you take of yourself is an image. And then you put it into Photoshop and you manipulate it and do all that crap to it. And those are transformations. No, seriously, the programming in Photoshop is based on everything you're learning this unit. It's just transforming the picture based on where it is on a coordinate grid. It's all this math. Okay? And so, oh look, on this graph, behold, yon triangle. Which one is the pre-image? Which one's the original?
ABC.
What?
The one without the...
What is it called?
Triangle ABC.
Oh, triangle ABC. Thank you. I was concerned for a minute that you didn't know what shape it was. It's the pre-image, and nothing's been done to it. But then it got transformed, and there's an image of it. What's the image called? Somebody else. Presley, what do you think the image is being called?
Triangle A.
And then it's got that little teardroppy looking thing up there that looks kind of like an apostrophe. That little apostrophe, you read it with prime.
So A prime, B prime, C prime.
Perfect. That's what that says. A prime, B prime, C prime. So the one without the prime on it is always your pre-image. It's your original. And then the one with the primes is your image. It's the, cheap imitation that you made after. Okay? Now, transformations can change lots of things in your picture. So what's something think about what you can do with stuff, how to change it. How can we change stuff? What can we change about this triangle?
Size.
We can change its size. I'm going to put that one at the end because that's the goofy one.
Position.
I can change its position or its location. That changes its position, doesn't it? I can change size and position.
Orientation.
Orientation would be that. So it's orientation, the way it's pointing. Orientation. Okay? And so if it started pointing up and it stayed pointing up, you haven't changed its orientation. But if it started pointing up and now it points to the side, you've changed its orientation. And so those are all different things you can do. Okay? Size is special because it is the only one that is not a rigid motion. So knowing that size is not considered a rigid motion, what do you think a rigid motion is? We know it's not a size change. So what is it? What do you think?
It's a position and orientation changing.
Okay, so what is preserved? What is kept the same?
The size is
Transformation that preserves or keeps what the same? the size the same, and what else? Will a triangle suddenly become a square?
Shape.
No, so it's going to keep the shape. Remember when we did similar figures? Remember, the size changed but the shape stayed the same? Okay, that's not a rigid motion. A rigid motion, you have to preserve size and you have to preserve shape. And if I preserve the size and shape, this is where I get to have fun. I get to do some art. Where's my, there's some. So if I take this triangle here and I decide, okay, here's my triangle. Doop, doop, doop. And I move it here. Have I preserved its size?
Yes.
Have I preserved its shape?
Yes.
What if I do this to it?
Yes.
Have I preserved its size and shape?
Yes.
Oh. Well, if I do that, and I haven't changed the size or the shape, how is this triangle related to the original? What relationship do they have that we have done over and over and over again all year? They're congruent. That's the one, go get candy for that. That's the one that says size and shape. So the image is congruent to the pre-image. Which, oh wait, congruent shapes implies what? Congruent
Parts.
corresponding sides and angles. So you can't just say congruent parts because they're going to move around. So you have to say, so they have congruent corresponding sides and angles. Okay? Because yeah, you're going to have to keep straight. If I rotate it, you're going to have to keep straight. Oh, this B prime was originally on top and now it's over here. And so it has to be the corresponding one, okay, that stays the same. Okay, so think of all, you learned in pre-algebra a bunch of different transformations. Which transformations are the rigid motions that preserve position and or orientation? A translation is a rigid motion. Okay, and so that is going to be, you know, where I take it and just kind of slide it. Okay, that's a rigid motion. What's another one that's a rigid motion? A reflection is a rigid motion. So if I have this guy and I flip him over, that's a rigid motion. Okay, now my mirror is somewhere, you know, in here. There's my mirror. But yeah, it's preserved size and shape. What's another one? A what?
Rotation.
A rotation preserves size and shape. It changes its orientation. Okay, so it's pointing a different direction now, but it's still the same size and shape as it was before. Okay, cool. You feeling good so far?
Yes.
Yeah. This is not intended to be a difficult day. That's why it's good that everybody who's gone has gone today, because they're going to be able to watch this video and figure it out. Hi guys, we miss you.
No, we don't.
Okay.
Miss you, Jack.
Who was that? Nope, we're not going to call out names, rude. Okay, so I need someone to tell me the definition of a translation then. That was our first rigid motion you told me about. So what is a translation? Yeah?
Moving the triangle's position on the plane.
Okay, do I change its orientation? No. Now, if you had to describe it to a 5-year-old, what would be a word you could replace translation with that would mean the same thing? A slide. 5-year-olds understand slides. You're sitting at the top, you go down the slide. If you're not a very uncoordinated person like me, then you're still sitting at the bottom. Okay? And so it's a vertical and or horizontal. I can't spell. Horizontal slide. Okay? Notice it's and or. Could you do both?
Yeah. Yes.
Yes. But notice what it doesn't do is change its direction. So I can slide it horizontal. I can also slide it vertical. Okay? So I can take this guy and I can slide it up and down, or any combination of up and down, but I don't turn it. It stays pointed in the same direction every time. Okay, so it's a horizontal slide or a vertical slide. You're very excited. Now, coordinate, the way we describe that in math is because, we got to do everything. We have something called coordinate notation. And what it does is it tells you how to change the coordinates. So we always start with your original coordinates, x, y. And then we're going to say they are going to move with an arrow. That's not an implied statement arrow. That's just an arrow saying you're moving. Okay? And then what I'll do is I'm going to say my x is going to move to a different spot. And I'm going to say how far it moves. So I'm going to call that distance it moves h. Which direction does x always move?
Left or right?
Left or right. It always moves sideways. Okay? And then I'm going to say my y is going to move. Which way does y always move?
Up or down.
Up or down, vertically. And so that one's going to use the letter K. H and K are good buddies. They're very similar to each other, so they get to stick together a lot. Wait a minute. Aren't those the letters we used when we did our circles equation? Yeah. Guess what we were translating on the circles?
Up, down.
The center was getting translated to its new spot.
Ooh.
I know, right? And so H represents your horizontal shift, or your horizontal slide, and K represents
Vertical.
the vertical movement. Okay? But there's a catch here. Okay? And to see what the catch is, I'm going to have y'all take this. Now, could you graph these?
Yes.
Yes, you could graph rectangle QRST. You don't have to. Then I'm telling you, here's a coordinate move. I want you to move all your XYs like this. You can graph it if you want, or you can just put, where would Q prime be now? Where would R prime, S prime, and T prime be? I want you to write down the coordinates for the image of those. I'm going to actually draw the graph for the people at home. Q is at -6, -1. R is at -3, 1. S is at 1, -5. And T is at -2, -7. And so that is my rectangle. That's the pre-image. Okay? And now I need victims who, this is your first time. Let's see who gets bamboozled. For candy, who's willing to admit what they guessed for what Q prime should be? Logan, what do you think Q prime is?
-6 plus, -1 plus 6.
-1 and +6? Did anybody agree with him?
Yes.
Yeah.
Y'all think you did it right? Let's see. I would have to take my -6 and go +5, which is at -1. And then my -1 has to go up 7, which lands it at 6. So let's see. -1, 1, 2, 3, 4, 5, 6. I'm graphing it. You don't have to. So there's Q prime. That's where you think it slid to. Okay, next victim. I need R prime. Yes, sir.
I got 2, 8.
So let's see. 2, 1, 2, 3, 4, 5, 6, 7, 8. So 2, 8. Does that look like it's doing the same thing as it was down there? So it seems pretty good. What mistake do you think is most commonly made here?
I don't know. Just adding.
People think that when you add, you go left. That's because it's in parentheses, right? And remember, it used to be that in parentheses, you always did the opposite thing. But that's when your parentheses is in an equation. Is my parentheses in an equation here?
No, ma'am.
Nah. That's why it actually gets to go the direction you think it should go. So my S prime, somebody wants candy for S prime, AJ?
6, 2.
6, 2, anyone want to argue with him?
No.
So S, go get it. So that's S prime, and then T prime, somebody who thinks they have T prime. Remember, you're going to take your T, you're going to move it up 5, and you're going to move it right 7. What do you think? 3, 0. 1, 2, 3, 0. Does that look like a rectangle still? Yeah. Did you need the graph to do the translation though? No, because my coordinate notation told me what it would be. And so you don't need the graph unless you want to just confirm that, yeah, did I do this right? Yeah, that looks like it's been slid and nothing goofy happened. Okay? Everybody try the next one. This one I need people who haven't raised their hands yet to raise their hands for candy. So if you know that's you, decide what you're doing. I'm going to draw the picture. So I've got C is at 2, negative 1. And then D should be at 7, 3, 4, 5, 6, 7, negative 4. That's D. And E should be at 4, 2, 3, 4, negative 1, 2, 3, 4, 5, 6. E. So here's my pre-image, triangle CDE. Could I have named this triangle EDC?
Yes.
Yes, but then when you name the image, you have to do the image letters in the same order, just like we did with the triangles in our congruency and similarity unit. So just watch out for that. Most of you are going to do that by instinct, but I have to warn you anyway. Okay? And so XY is going to, which way is it going to go? Someone, okay, here's another opportunity for candy. Predict. Which way is it going to go if it's -3 and +8? What do you think? Left how far?
3,
And then
8, up 8.
up 8. So it should go left 3 and up 8. Let's see. Get your candy. And then does anybody have C prime already? Okay, Natalia, what do you get? -1, 7. Let's see. -1, 1, 2, 3, 4, 5, 6, 7. Is that taking my C going left 3 and up 8? Looks like it to me. So I think that's C prime. Good job. Get your candy. Next victim. Who thinks they have D prime? Ibrahim? I'm sorry, I couldn't hear you. 4 and 4. Let's see. 4, 4. 1, 2, 3, 4. 1, 2, 3, 4. We think that's D prime. Let's see. Did I go left? 1, 2, 3, and up 8. Looks pretty good to me. And that side looks like it's pretty much in the same position. You know how you can tell it's in the same position? You can check its slope. The slope should be the same.
Does that mean they're parallel?
Oh, they're parallel. Oh no, all that old stuff from algebra is coming back to haunt us. Dang it. E prime. Here's another person who hasn't gotten candy yet and really needs the Smarties.
1, 2.
1, 2. Let's see if he's right. 1, 2. Let's see if that looks good for E prime. Do the triangles look the same? Yeah. So this is a good way to verify, but you do not have to draw. Oh, make sure, if you do draw it, make sure you put the primes. Don't leave the primes off. Optimus would be mad if you didn't give him his prime. Do you wonder now if they purposely called him Optimus Prime because transformations involve writing stuff with primes? Have you ever thought about that?
Well, he's in his prime.
Are you going to think about that now? Yeah. I am ruining it all for you. Would you like to do more examples, or do you think you've got that figured out?
I think
Got that figured out.
Okay.
Thank you.
So now let's ruin another movie for you. Vectors. So now, of course, you remember Despicable Me, right?
Yeah.
Yeah. And who was our antagonist?
Vector.
Vector.
Oh, yeah.
And what was Vector's symbol?
The V?
The orange.
V.
It's not a V.
Oh.
It's a U. It's a D.
I'm committing.
It's an arrow.
Oh, really?
Oh, yeah.
So now everybody's going to go during lunch and look it up online now. It's an arrow. Okay?
Yeah.
Because a vector,
Oh, yeah.
a vector is just a movement.
He's moving the movie.
It's just a movement. And movements can be measured in two ways for us. When you get to physics, you'll get a lot of other ways, but for us, you measure them two ways. What are the two ways we can measure it with? They've got both what? But here is a movement.
Direction and magnitude.
It's got direction, so I can tell which way it's going. And what else? Magnitude. What is magnitude?
I don't know.
Oh, how
Didn't
big
he say-
How big it is. That's its size. Okay? So a movement has direction and size. When you get to physics in a couple years, that size, that magnitude might indicate how fast something's moving, or how much it weighs, or something like that, the force behind it. But then it will also have a direction. But for us, guess what the magnitude is talking about? It's length, how far it goes. Okay? So that magnitude is going to be how far our vector moves, and then it's going to have direction. Okay? And look how we draw it. A vector is drawn using an
Arrow.
arrow.
Right.
Oh wait, didn't we just use that before?
Did we?
You didn't even know it, but you were doing vectors. You were doing a movement.
I moved that.
What did we move? We moved a point. We moved that point in a direction
And magnitude.
and magnitude. Okay? Shh. So it's drawn from an initial point, and your initial point is always going to be on your pre-image. Okay? So it's going to be on your pre-image. And you're like, wow, this is so hard and scary. And then you're going to go to an end point on your image, but we're not going to call it end point because that's too boring. So instead of end point, we need something snappier for the ending point.
Final point.
Final points is good. That's not tough enough. So we need to ruin another movie for you.
Oh, no.
It's going to be a terminal point.
Terminator.
Because to terminate means to end. So if you go to the terminal at the airport, does that mean that's the end of your journey?
It could be.
It could be.
Or it's the beginning.
Or it's the beginning. But so it's somebody's ending there and somebody's beginning there. But it's terminal means ending. That's kind of creepy though. I'm going to go to the airport to be terminated.
They should have named it something better.
English is goofy, isn't it?
I like that. Yeah.
English is goofy. Okay? So that's your end point. How do you guys, shh, how do you tell which one is the initial point and which one's the terminal point?
Arrows
The
point to
end point, the terminal point is the one where the arrow is pointing.
Yeah, the terminal point is the one where the arrow is. You start without the arrow, you end with the arrow. Okay? Okay? And so to name this vector, someone want to guess a name for this vector? This vector right here, this pink guy. We need to name it. It needs a name.
Northeast.
What should we call it? No, that's a compass direction. That's not a vector.
Vector.
Yeah, but we need to name it. So here's my vector. It's this arrow.
Vector P.
Okay, what should we call it?
Vector
Vector what?
David. PQ.
Oh, now, should it be PQ or QP?
PQ shows PQ.
From initial to terminal.
You should always go from initial to terminal. So these do not get to be forward and backwards. Remember how when we named rays,
Yeah.
you always started at the point and ended where the arrow was going? Same thing. So this is going to be PQ, and since we draw it with a ray, guess how we're going to draw the symbol for a vector? With a ray on top.
Oh my goodness.
So how do you know to call it vector PQ and not ray PQ?
The letters are capitalized.
No?
You just gotta look at the picture.
You gotta know the context.
Yeah.
You could think this is a ray, but it is denoting a vector of magnitude and direction, okay? Rays can be used as vectors, and so you just have to know what we're talking about. That we're talking about its direction and stuff, it's probably a vector, okay? And here's how you read it. Vector PQ. Are you astonished yet?
Yeah.
So astonished people are tattooing it on themselves, I'm sure. Okay? Now, so I want to write how far this vector is going and which direction it's going. How can I do that? Could I just calculate how long it is?
If you wanted to.
If I wanted to use the Pythagorean theorem distance formula, but that would stink, right?
Yeah.
So we're lazy. And the clue to how we can write a vector without having to figure out how long it is actually hidden in here. Remember, this is a vector, isn't it? But it's written in coordinate notation. What told me how far to go?
I don't know.
X.
The H. Okay. And what told me which direction to go? No. Well, plus, but also how did I know to go left or right? Or up or down?
The X.
If it was in the X thing getting changed, we knew to go sideways. If it was the Y thing getting changed, we knew to go up and down. So watch how lazy mathematicians are. We're going to take this coordinate notation and make it even shorter for my vector. So for my vector, I'm going to say, okay, I'm going to want my sideways amount to move, so I'm going to put it in the X position. So I'm going to put a letter in the X location, and I'm going to put a letter in the Y location. So whatever number is in the X location tells me how far sideways I want to move my vector. And the Y amount, what's it going to tell me? How far up and down my vector will go. Okay? And since it's in the position of the X, do I need to write the X? No. I can just know that the X thing goes first, and so that's what's there. Now, how do I keep from confusing this with a coordinate, though? Should I use regular parentheses here? No, because then you'll think it's a point and not a vector. So what would be a good thing to use instead of parentheses to show that this is a vector and not a point? What? A bracket, but I need a bracket that says vector. So does a curly bracket say vector?
At the end of an arrow.
The end of an arrow is a good bracket, so I'm going to use arrow brackets.
You will.
To show that it's a vector. Okay? So, so what this says is that if you, so our vector PQ equals this vector. Okay? So in this picture, what is we call this component form because I've got a horizontal component and a vertical component. Do you know what components are? Parts. So I've got a horizontal part, a horizontal component to my vector, and I've got a vertical part, a vertical component. So this is called the component form of your vector. So in this picture, what is the component form of my vector PQ? What would I write? First, I'm going to put my arrow bracket. And what's going to go in that first slot?
4.
And what kind of 4? How do I show it's going right? A positive 4. Do you have to write the plus? No, you get to be lazy. But if you see a positive 4, you know it's going right 4. And then how far up and down is my vertical component? Is it 7?
Yes.
Okay, because that's too small for me to count. So vector PQ is written in component form as 4, 7 with the little arrow brackets. Okay? So here's where you guys are going to get to earn candy. I want everyone to write down the vectors and their component forms for these vectors. So here, what's my vector here? It's WV, so you write WV, and then what's its component notation? How far to the side is it going? Really? From W to V it only moves 4?
Sorry.
Remember, it's horizontal component first. It moves 9? And then how far is my vertical component?
3.
Oh, I heard 3 and 4.
3.
It's at -1 here, it's at 2 here, that's a distance of 3 in the up direction. Okay? So my vector WV moved 9 and 3. I want you to do that for all the others, and then I'm going to pick 6 people at random to see if you get it right, and people who get it right get candy. You already did them?
No.
Okay.
The homework ones though.
Okay, we'll do the one on the notes now because you want to have a chance to earn candy, and you don't want to anger the teacher.
Yes, sure.
Be careful. Pay attention to your initial point and your terminal point. In fact, I think we'll call people up to write the form up on the board. Because then if they get it wrong, they still get candy.
Sure.
Because they were willing to do it in front of people.
Okay. Sure.
But they want to get it right so they don't get mocked.
Okay.
No, this one's actually a WV, not okay.
Okay.
Do I have a volunteer for number 6? Okay, I've got number 6. If you want to come up and write the vector and its component form. Do I have a volunteer for 7? Okay, come on up. Even if you're not done.
I haven't done this once.
Oh, you're doing it on the fly. Good for you. Does anybody want to try number 8?
Too blurry.
You want to do number 9 because he claimed number 8?
Is this an R and A?
This is an R and this one is S.
Uh-oh.
If you need to bring your paper up so you can read it because it gets blurry up there.
I need to check my paper.
Yeah, check your paper.
Oh, yeah.
So write the name of the vector and then its component notation. Interesting. Do I have a victim for the last one, number 10, now that not so many people are up here? Anyone want to try it? Still get candy even if you mess up. Okay, we got somebody coming up.
Can't wait.
Go get your candy and then we'll see if you're right. Yeah, bring your paper if you need to.
Oh, yeah.
It gets blurry up there on the overhead.
Oh, yeah.
All right, let's see how they did. Now for the people at home, I have to write it on here. So the first one said that this was vector BA. Wait, isn't the A first?
No.
How do you know that A is not the initial one? Abigail. Yeah, the arrow is up here by the A. So we know that's the end. So B is the beginning, A is the ending. Okay? That's going to mess up your direction. So if I start at B and go to A, I'm still going to have the same sideways magnitude, which is how much? What's my magnitude here? Was it 5? But if I'm starting at B and going to A, you have to make it negative. And did he have that right?
Yeah.
Okay, and then what's my vertical component?
1.
Up 1? And that's what he had? Awesome. Good job. Next victim, number 7, he says it's SR as a vector, which I agree with, which is my very favorite airplane, by the way.
SR71.
SR-71 Blackbird, the sweetest plane ever built.
Oh, yeah.
Still the best. They're gorgeous. Look them up. SR-71. Type it into your search engine at lunch and see. It's an awesome looking plane. Okay?
A masterpiece.
And so, and he says the magnitude was what? -2? And is that 0 or 10?
-10.
-10? Y'all agree with that, or do you think it's wrong? It's 11? Is it 10 or? Oh, the shame. I don't know who did that one, but it was 11. Someone. Notice. Look. Well.
It's too blurry for me.
Yeah, well, you have your paper. You could have looked on your paper.
I didn't do it.
Rip. okay? And so this one's vector BC, and its component notation, let's see, it's going down 2, so that's my y, and it's going right 2, so that's my x. Did I match what they had? Okay. And then this one is vector MN, and they put 0, 6. Wait, you can have zeros in vectors?
Yes, ma'am.
Ma'am.
Yeah, as long as you don't divide by it. Now, hold on a minute. What would be the slope of this vector?
0. X is 0.
Rise over run? What? Oh, that breaks the first commandment of math.
Yeah, you
That was undefined.
So this has an undefined slope, but we can still write its vector component notation without breaking the rules of math. Because we can't write it as a 6 divided by 0, so it doesn't have a defined slope, but it does have a vector. Okay? Which is always fun to play around with. And then my last guy is horizontal, so let's see, that's going to be HG. And they said it was, the up and down was 0. How far sideways did they say? Negative
Negative
11. That one's also 11? And that's correct? Okay. Because we didn't go up or down, but we went left 11. Okay? Y'all good with vectors?
Yes, ma'am.
Yeah.
Okay, now I'm going to go back. I'm going to come back to this first page to show you something.
Wait,
What?
is a vector pretty much the coordinate notation?
I'm about to show you. Okay? So notice something. Your coordinate notation of the movement is actually very similar to the vector. Because look. Hi. So I'm going to draw the vectors. Q goes to which thing? Q prime. There's the vector. And how far did my vector Q prime go? It went 5 to the right and 7 up. Oh, what about my vector T to T prime? How far over does it go? 5. And how far up? 7. What do you notice about all of my vectors?
They're all 5 centimeters.
They're all 5, 7, which means they'll all have the same slope, which means they are parallel. They are also all congruent because we're moving in the same magnitude. But since we're moving the same magnitude and the same direction, that's what gives it the same slope. And so this is also a good way to draw 3D shapes. Because look, I've got two triangles that are the same. If I draw their vectors, now it looks like a prism. That's how you can do a box too. Just connect all your vectors and you have a box in 3D. Pretty cool, huh? Yep.
Now how are we going to do the
Yo, you don't have to draw anything on your homework. Okay? Shh. So, real quick, just like we did here, see how I gave you the coordinate and gave you the coordinate notation for the translation? Here, I'm going to give you the coordinates and I'm going to give you a vector to move it on. Can you still figure out the image points? Do you need to draw the picture or can you figure them out just from the vector?
Figure it out.
Okay, I want everyone to just do number 11. Just number 11. I give you STU. There's STU. And I want you to follow the vector components to see where it ends up.
We don't have to draw it, right?
You don't have to draw it. I'm drawing it so that we can see if it works, so you know I'm not lying to you because you know I like to bamboozle teenagers for fun, but also to help people who are watching it at home. So S is going to move to S prime. Who hasn't answered something yet? Point out the people around you who haven't answered yet. I know I called Abby's name. I know I called...
I haven't done this yet, so don't call me.
Okay, don't call on you. I don't think... Olivia, have I called on you? I don't don't think so. Okay, so what is S prime gonna be?
Negative 5.
-5, -3? Let's see, -1, 2, 3, 4, 5, -1, 2, 3. Let's see, that moved left 1 and down 5. Is that what it says to do, left 1 and down 5? Oh, look, it followed its vector. Beautiful. So there it is, T prime now. Who else have we not picked on yet? Have we actually gotten everybody? I don't think I've gotten you yet. So where is T prime going to be if I go left 1 and down 5? 4, -6. Let's see, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Should be T prime. That looks like it's left 1 and down 6. Yep. That looks like left 1 and down 5. Oh, wait, that was too far. Left 1 and down 1, 2, 3, 4, 5. I counted wrong on that. So should it be at -6? If I started at -1, oh, I graphed this wrong.
Yes, I noticed.
You didn't catch that I graphed T wrong?
I just saw it.
This is why we don't force you to graph it, because if you graph it wrong, it could mess up your numbers. T should have been at 1, 2, 3, 4, 5, -1. That's where T should have been.
Yeah.
So the T prime ends up at 4, -6 down here. There it is. There's T prime. And then there's my vector. And see, look, they're parallel. They're parallel vectors. I got it right this time. Okay. And then U prime? Yes.
-3, -7.
-3, -7. So -1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Let's see. Is that left 1 and down 5 from my original U? Looks like it is. So there is my translated image using vectors. Wow, was it almost exactly the same as doing it with coordinate notation?
Yeah.
Wow, you're impressed. So, go backward. I have given you 2 translations. I want you to write the translation both ways. With coordinate notation, meaning you start with xy and then tell me what xy moves to, and then your vector in your component form for both of these. You really only have to do it for 1 point each because they should all do the same thing, right?
Right.
You're writing the translation in coordinate notation, so xy goes to what? No, that's just a set of coordinates. I want your coordinate stuff here. Coordinate notation and vectors in component form. So my coordinate notation, remember, starts with any old xy, and then you're going to use along a vector to move it to a new location. And then your vector just tells you how that vector moved in your component form. And once you know one, you know the other, huh? That's the nice part about these. Okay, so for this first guy, what's my coordinate notation? XY mapped to what? I'll grab it with handy again if I need to. Camila?
X plus 7.
X plus 7, so let's see. You say it goes right 7, and then how high up?
1
Plus 4? 1, 2, 3. I believe it. Okay, so what's my vector then going to be? Yes?
7, 4.
Wow. That was so hard. You almost died. There's your vector. Okay. Now do the next one. Last one, and then I'm going to turn you loose. I know you can do it. I believe in you.
Go right 4, down 2.
Okay, so XY is going to move to what? I need somebody else. Nicole, I don't think I've said your name today. Nicole, what does XY mean to in this guy?
X plus 4, Y minus 2.
X, so you're saying that this point goes to the right 4 and down 2? Oh, do you have to pay attention to where the primes are?
Yes.
You want to start with the pre-image, which does not have primes, and so if you're starting here, this is a common error, is people always want to default to the one that's at the left first. But pay attention to your primes. This one, we're starting here and moving this direction, so we're going to be going left 4, and then right plus 2. And so then my vector, last chance for candy. Somebody with a sucker already in their mouth, yes.
-4, 2.
-4, 2. Okay.